Blobby builds break before they're finished. Persistent patch plagues print plate. And big builds equal bad bonds between walls. And oh yeah, Creality's infringing on our name. All this and more, PrintFix Friday, episode 227. Let's get into it. Starting off here, we got a user with a Flashforge AD5X that, yeah, some things aren't working. I don't even have to have the sound on to tell you that's going to sound all crunchy and crinkly and, well, you ain't hot enough. You're not hot enough or you're going too fast. Technically, it's a bit of both. If you want to go that fast, you need more temperature. So what is happening here is that you are outrunning your hot end. Your hot end is not able to flow the type of plastic that the printer is currently asking it to do. And so instead of being able to get the plastic molten, generally the core, the inside of the plastic, is staying relatively solid and blocking its ability to come out of the 0.4 nozzle that comes stock on the AD5X. This is not that big of a deal. You can say, I still want my printer to print this fast, so you throw a bunch of temperature at it and hope for the best. Sometimes it works and sometimes you burn your material. The best way to take a look at this is inside of the slicer. If we look here for, in this case, the Cheaty Plus 4, under your material settings, you will see a nice little thing here called volumetric speed. This is the maximum volumetric speed the printer will physically be able to print at. In some cases, it's set higher from the factory than is actually reasonable. Or you just have your temperature too low for this material. Remember, if you're gonna run high speeds and high flow, you often need to up your temperature accordingly as well. For PLA, we're seeing easily 220 to 230 C, and for some PETGs, as hot as 270. Although some of these higher speed PETGs want colder temperatures because they're not pure. And if you guys want to see an investigation into this where we do some actual testing with load cells and real testing, and then maybe some random Florida man stuff, let me know in those comments. And hey, speaking of Florida man, my name is Grant. This is 3D Musketeers, and PrintFixFriday will help you get your printers back to printing with purpose. If you want to get help fixing your prints and your fails, you can reach out to us on all the social medias. Although, filming a video and tagging us in that description when you upload it to YouTube is the best way to get our attention. But with this Flashforge AD5X here, I think the easiest option is to immediately slow the machine down, and then you can look at adding speed, adding temperature, adding speed, adding temperature, until you decide, hey, we're just getting too hot, or hey, we're already at speed, this is the temperature we need to be running at. It's a very common thing. This is the fun problem with input shaper 3D printers, is you can quickly outrun your hot ends, and that's why we see a lot of brands going to high flow hot ends, some of which are choosing to actually follow the rules and use CHT. Others are choosing to find ways around the CHT patent, and the CHT system and most of the other systems basically give more surface area to the filament, whether they're breaking it up and then putting it back together, or they're squishing it into a different shape. It is giving more surface area to that filament, allowing it to get more heat, therefore getting heat where it's needed, getting it hot enough so it can print faster. For reference, a stock Bambu X1 carbon, good for about 15 to 17 cubic millimeters per second with PETG, and I think they even limit it to like 12 or 14 from the factory. You put on the high flow from E3D, 30 is pretty easy to achieve. Like, we run closer to 35. And the only difference there, the temperature is exactly the same. The only difference there is how that material is being heated up. It's a more efficient way of heating, and hey, better efficiency, better speed.
Papa John's.
Next up, we got a, well, looks like a Bambu A1, could be an A1 Mini. And yes, we are still following that A1 fire hazard issue, so please keep tagging us online and sending us the fails as you guys see them. And again, we are collecting those dead boards to get tested. We are still working on the investigation. We are going to make certain that Bambu is held accountable for this. Anyways, we've got a first layer here that it's constantly having issues. This was the best first layer after retries. Why does this happen? They didn't say it's happening in the same spot, but I'm almost positive that it is. We can see that the first try was a big mess. Second try was torn up, but we can see some spots here on the build plate. Your bed's dirty, homie. You gotta clean it. Your mitts, they be greasy. Not too oily. Calm down, United States. We don't need to bring in the choppers and abduct 3D printer users because their hands are oily. Calm down. I know a lot of people go after alcohol, isopropanol, whatever. We don't recommend that. One, because it's not compatible with every build plate on the market, but two, it doesn't do a great job of removing the oils. Tends to just kind of spread them around. Ammonia-based glass cleaner, like Windex or any generic version of it, works considerably better. Like, way better. You will end up spending way less money, it lasts longer, and you can use it to clean the glass on your enclosures. So you're welcome. But ammonia removes grease. That's why it's great as a glass cleaner. And from our knowledge as of right now, there are no build plates that are not compatible with ammonia-based glass cleaners. You can use it on everything from the cryo grip plates from Big Tree Tech, Tyson build plates, textured build plates, smooth build plates, cold plates, don't care. Your plates, my plates, it works. And it's awesome, and it's way more affordable than alcohol. This one might be a little bit odd for you youngins out there, but if you hold build plates like albums, like record albums, you know, LPs, 45s, the things that make the scratching noises that your parents know all about and you should never do with an actual turntable. If you hold it by the edges, never actually touch the disc itself, it will keep it cleaner. Same thing with your build plate. Hold it by the edges. There are designated places to hold build plates. On an A1, there's a little piece in the front, and then those two little wings right there in the back. Those places don't get printed on, so they're totally fine to put your hands on. Try to keep your hands off everywhere else on the build plate. If it is maybe oil or something that dripped from your rail that looks recently lubricated, same deal, a little bit of ammonia-based glass cleaner, life is good. If you haven't tried glass cleaner yet, or you went back to a different method, we'd love to know what it is. I know a lot of you are fans of the, you know, soapy water and all that. Meh, it's too much work. Ammonia-based glass cleaner works perfect. Been doing it for over a decade. I don't intend on changing anytime soon. Speaking of things that probably should change, but probably won't, Creality, what the actual f***? Like, honestly, did nobody in your f***ing marketing department have two brain cells to rub together to Google 3D Musketeers? I've reached out to you via email and via social media, and you've ducked me for weeks. So now I'm gonna call you out. You are hereby put on notice. If I have to get lawyers involved, I will. I was initially going to be very nice about this. We could have solved this very politely. It wouldn't have been a problem. But if you want to duck me, don't get me wrong. We can come knocking. Also, it's a really dumb name for a product that has 4 things for filament. I understand that you say that it can do, you know, 3 different things, you know, 4 color sealed storage, auto identity, meh. Or it could be the, you know, 3 different options you offer, but you clearly don't know the story of the 3 Musketeers because there's 4. Where's D'Artagnan? Where's D'Artagnan? Everybody forgets about D'Artagnan. Guys, Creality, fix it, please. This isn't difficult. Like, just change the verbiage. How did you all literally work with us? You literally work with us. I have WeChat numbers for more than a couple of your staff. How did nobody question this? And if it was deliberate, why did you not come to me first? If you came to me first and asked, this would be a completely different story. And if you actually responded in a timely manner, you've had more than a week, this would be a completely different story. But it's not. This is ridiculous. Fix it. Moving on. Any idea why the last layer is so rough? What do you guys think? Yeah, the hot end broke. The hot end broke. It's over there. Filament's coming out of there. We want to determine why. Why is that top layer so rough? It is likely because the hot end itself bent bad. And when it bent, it was still trying to print, but it didn't. And then eventually it just broke, and we can see the raw filament itself being pushed through the machine. Thankfully, that filament's actually not a waste. You can just rewind it back up and everything's good to go. We've seen this happen before. This is why we always recommend to add a lot of extra Z-hop. I know that most printer profiles only do like 0.2 millimeters, maybe 0.4 if you're lucky. Go to 0.8, go to 1, go to 2 millimeters of Z-hop. Who cares? The couple of extra minutes it is going to add to even a large build is absolutely worth it, because a Hotend is way more money than dealing with a couple of extra minutes. Quite frankly, it's safer anyways. With machines that can move at ridiculous speeds, as we've said, Mach Jesus. These machines, any modern machines, move at Mach Jesus. Inertia's kind of a problem. And if your machine is moving at Mach Jesus, with accelerations known to be faster than a Corvette ZR1X, that's a reference car guys will get, you have to be careful. If you don't get the print out of the way that could be warped up a little bit, you're gonna smack it. And like new drivers and curbs and drive-thrus, they tend to be attracted to each other. I look at this and say, Z-hop would have solved our problem. The only thing to do right now is just to completely change out the Hotend. Likely it was bent a little bit, then it got bent a lot of bit, and then it completely broke. It seems like this is becoming more of a thing that we see with high-speed 3D printers, that the nozzles and Hotends and all that end up becoming sacrifices to the 3D printing gods, where back in my day, if you hadn't burned yourself on a Hotend, you weren't really a 3D printer. I feel like the new version of this is if your printer hasn't broken its own Hotend because it is moving at crazy fast speeds, then you're not really a 3D printer. I don't know. In your head, what is that line before you're a real 3D printer? And this is not like gatekeepy or anything like that. I'm looking to have a little bit of fun in the comments. And hey, while you're down there, don't forget to leave a like. Get subscribed if you're not. This stuff's fun. I promise. Moving on to walls and perimeters not adhering to the print. Let's take a look at this video here. We can see it's a decent part. A little bit of VFAs, but you shouldn't have that. It shouldn't look like a drum. There isn't audio, so imagine it. Some VFAs when they turned it over and some ghosting, but we're going to ignore that for the time being. So we've got a fun issue here. This is technically under extruding. This is an A1. And they said, yeah, printed for 12 hours PETG, it looks great, but the walls didn't adhere to each other for some reason. Why would this even happen? They printed it at like 75 millimeters a second at 245C. This is almost certainly an issue with your extrusion and pressure advance. It's most likely more on the extrusion side of things. You want to make sure that your printers are actually extruding what they say they're extruding. If it is extruding less than expected, your walls aren't going to overlap each other like you're expecting them to, so they're not going to stick to each other. And then the infill that is supposed to contact that wall for a certain percentage isn't going to work the way you want either. If we bring back Orca Slicer, we can see here under the Strength tab that, you know, your sparse infill density is normally 15%, grid infill, which is terrible. Please don't ever use grid. But the infill wall overlap is 15%. If you leave your mouse over things in Orca Slicer, it does a great job of showing you, like, what it should be. Yes, the value is normally between 10 and 15%. For stronger prints, we go as high as even 25%. But note, if you're only using 2 or 3 perimeters, that is not enough to not see the infill on the outer walls. We'll do parts that have like 6 or 8 walls or even 10 walls, and then you can run 25% overlap and you're not going to see anything. You just have to be careful. You don't want too much overlap to where your infill becomes visible on that exterior layer. But in this case, nothing is visible because the friggin' layers are, while they're sticking to each other, they're not sticking to each other. You feel me? So what can you do here? It is an A1, so I would highly recommend running a flow calibration. We can go inside of Orca Slicer and just grab the YOLO, try it, and see what it is. And then inside of your actual settings for your filament, That's where you put your flow ratio. For this Sunloop ETG on the Cheaty +4, we are flow ratio of 0.985. That's what it was. That's what it showed. Same with pressure advance, you can check that stuff too. The user did also show us some of their settings. And their settings showed that they don't have gap fill turned on. We generally recommend to have gap fill turned on. It's just easier. And yes, you can filter out tiny gaps. That's no big deal. Go ahead and do that if you'd like. And sparse infill pattern gyroid. You don't need that high of gyroid if you're going to use it, but there are much better infill patterns out there that will print much faster. I'm a adaptive cubic guy myself. I don't know. What's your favorite infill? Let me know in the comments. But similarly, we've got another individual having the same problem where the layers don't stick together vertically. Same, but a little bit different. Instead, in my opinion, of this being flow rate, I want you to look at your belts. I want you to look at your pathing, and I want you to actually measure if a 20 millimeter cube comes out to be 20 millimeters. So we can see that everywhere else, except this one little area here on, in this case, the bottom of the part, it looks totally fine, and it's fused. Now, that could just be from the first layer. They don't actually tell us that. You do want to check and run a flow rate calibration just to make sure things are right. Every material will have different flow rate properties, and especially materials that are high speed versus traditional. It can matter, and it can matter a lot. So if you're not certain, run a flow rate calibration. It's simple. You don't have to do it all that crazy, but it'll at least get you a decent starting place for it. In this case, I don't know for sure if flow rate's the right place. If it is not sticking together all the way through the part all around, and it just is down here at the bottom because of that first layer, then yes, look at your flow rate. If it is just in that area and it's the same thickness all the way around in your actual slicer, like your walls are concentric with each other, then I want you to look at your belts to make sure that things aren't a little bit misaligned, or maybe your carriage could be a little bit out of alignment. When things are out of alignment, you can get more ovals rather than circles and perimeters that don't 100% touch each other. But this could also be pressure advance. There's a few things that it could be. But let's start with running that flow rate calibration. I think that's a good place to start, and then try this print again. But do check it to make sure that it is concentric. If it isn't, and it is supposed to be, make it concentric, but do make sure that gap fill is turned on. Gap fill will matter here as well. I've had issues like this in the past, and it's normally solved by flow rate calibrating or checking belts. But because it is an AD5M, it is a Core XY machine, I want to check those belts as well. I know that traditionally we say that belts don't matter, and they don't on your traditional bed slingers. On Core XY, it's a big deal. If a belt is even a little bit over tensioned or under tensioned compared to the other one, you can run into some serious problems, and you'll be chasing your tail for days trying to figure out what it is. And in reality, it's because one belt is much tighter compared to the other one. Two instances of very similar problems that are happening for potentially the same reason, but this one being TPU, I don't know. Depends on the TPU. Let me know what you guys think in those comments below. And what are your thoughts on this Creality thing? Should I legitimately even care? I've been like waffling over whether I care or not, because like there's some portion of it that is somewhat beneficial for us, and there's no way that people would ever confuse the Spark X, the 3D Musketeers, but they spelled it out. They must have known. Like, they must have known. But yeah, huge thank you to all of our Patreon members, Discord members, and YGK, 3D, and a few other creators who sent this over my way to get my attention. I know Sam Prentice did as well. So thank you all for getting our attention on this one. Layers with Lily, too, I believe. She's in this list right next to me. She's pretty awesome. At the $10 tier and higher, you get to come hang out in our private Discord. $5 tier and higher, you get your name in lights right next to me. But that is all we have for you all today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. All right, I'm just going to unplug this because it is in my way.